Okay, AP Computer Science A. We're going to do another demonstration. So we're going to go to BlueJ. And it will probably open up your last project. So I'm going to close that. I don't want a bunch of projects open. We're going to go to Project, New Project. So every demonstration, every homework problem, assignment problem, we're going to do in a separate project. Should have them all in the same folder, a Unit 1 folder right now. And we're going to name them all in the same format. P1, I'm going to go X. I'm going to go alphabetical usually. On the assignments, they'll say, P1X project. So we're going to name each one just like that. Okay, so opens up a project, which is really just like a folder to hold all the files for some new program you're gonna write. So we're gonna go new class because everything in Java belongs to a class, which is what we're gonna build our programs off of. And this is where you can kind of give it more of a specific name to what the program's about. So let's call this one guessing game. We use camel notation, capital letter first for class names, lowercase rest, capital letter for the first letter of any other word in it. No spaces, no dashes. Okay, we're going to open it up, double click on it, and we're going to get rid of everything that's in here. You guys should be getting kind of good at that. We're going to do public class and then guessing game. Should be the same. Curly braces open. And I like to maybe give myself a little bit of room to work with. In curly brace, comment at end class guessing game. So it's just to make it very clear to me and you where things are. Now we're going to tab in and we're going to do public static void main parentheses string capital S args regular brackets close, okay, curly brace, and oops, I'm gonna tab in, and close curly brace, and I'm gonna comment right now, end method main. So this is a method. Okay. Now we don't need to put the semicolons after these lines because they have the curly braces that kind of hold everything in. But any other kind of line of code needs a semicolon after it. Now, what we're going to do is we can kind of play around with something. Let's just try it. Let's do system.out.println. You're getting used to it. We use that one a lot. And then in the math class, I've shown you guys a math class before. I showed you like a square root thing, math dot. That kind of gives you access to a collection of things that are in this math class. And one of those things is a random number generator. And it's called random. It's a method. And it doesn't take any arguments, but it's a method. And any method will need parentheses for what's going to get plugged in. So we're going to just put empty parentheses there. And close those parentheses and then put this. Now we're going to print this out and just try it and see what it gives us. It's a random number generator. So let's compile this and then right click and let's run it. And that's the number printed out there, 0.9 to whatever. Now I don't want to erase this. Let's keep this. Let's print some other numbers. So I'm going to run it again. Okay, now when you guys run yours, you're not getting the same numbers as mine because it's random. And I want you to run yours right now. And that'll be kind of give you a better idea of what. So you see all these numbers. Now here's the deal. The random number generator gives you a double, a decimal, between 0 and 1. Okay? So let's write some little comments about this in our code. So, and we're gonna comment this out. And so let's put some notes in here. Math.random returns. So the thing it gives you, we say it returns a number between 0, and it can actually give you equal to 0. So it's greater than or equal to 0, and it's a double, and then it's less than 1, but not or equal to. So that means it's going to give you up to 0.9999999. Okay? But never actually gives you 1, but it could give you 0. Okay? So there's some things that we can do with this. Like, well, let's create a guessing game. Well, we're going to ask someone to guess a number between 0 and 10, and we want to create a random number. Okay? So there's no bias or anything. You're not going to pick my favorite number because I'm not actually picking it. So I don't want a number. If I'm trying to get someone to guess a number between 0 and 10, well, 0 to 1 is not going to help. So what we can do is we can scale the number, which is like a word for making something bigger or smaller. We can scale math.random by multiplying by a number. Okay? So we're going to create a random number. So let's create a variable for this. Now, so a lot of times what we'll do in programs is create the variables we're going to use like at the beginning. So I want it to be an integer. I don't want to make you guess a decimal. So, and I'm going to call it random number. So let's use really, good descriptive names. Random number. Okay, camel notation. You have to start with a lowercase letter for the first letter of a variable name. So this just declares the variable. We haven't initialized it. So down here, I'm going to put a random number in it. So I'm going to say random number equals math.random. So this will give us a decimal. Okay. Now, this is going to potentially create some problems for us. Let's see. I mean, because it gives you doubles and we want it to just be an integer. So how does that work? If we compile it, it says no, you can't put a double into an integer. Incompatible type. So you guys are going to get used to these error messages and you'll know what's going on. And you'll get used to seeing this pop up in other situations. Oh yeah, okay, I'm trying to put the wrong thing in the wrong thing. So this is supposed to hold an integer and we're trying to put a double in it. So what we can do is we can force this double to become an int. It's called casting. Okay. So the way you cast it is you put parentheses and you put int and you close parentheses in front of it. And what it does is it says, okay, take this thing and turn it into an integer. Okay. Now what's going to happen, so I guess we could put a little comment about that, maybe even before we do scaling thing. So we can cast double to an int. Okay. The way you do that is you put this in parentheses. The parentheses are needed in front of it. Okay. So now if we do this, it should compile. And also, by the way, if we print this out, I mean, maybe we can do a system.out.println. and print out the random number. So it's good to just maybe put out some printout statements, even if we don't want to tell them what the random number is before they guess. That's dumb. But for our developing this code purposes, that could be good to just check, see what's happening. So let's compile it. Let's run it. Let's see what's happening right now. So let's see. Hey, it gave us 0. I feel like that's a pretty lucky. That seems like a pretty extreme case. Let's make sure it gives us different things every time. Oh, 0 again. Okay, so here's the deal. This is what's happening. When it casts it, okay, from a double to an int, it truncates it. That means it cuts off the decimal part of it. And if it only could be 0 to 0.9999 and you cut off the decimals after the decimal point, guess what? It's always going to be 0. Okay? So now let's go to the scaling thing. So we can multiply this by some number. Let's say, well, if we want a random number between 0 and 10, let's multiply it by 10. So that little star asterisk symbol, that's multiplication. Don't put X. So that would multiply it by 10. Okay, now let's see if this works. Compile. No, it doesn't like this. You know why? Because in Java, often when you put something in a lot of code, it applies to the very first thing that follows it. So it's saying, oh, you want to change the 10 to an integer? Got it. And then they're going to multiply it times this random number. So what we have to do is we need to put parentheses around this to make sure that the times 10 happens first, and then we change that decimal. So now if you multiply by 10, you're going to get 0 to 9.99999. You'll never get 10 though. So we'll talk about that. If we want it to produce 10, that's an extra challenge. 0 to 9.9999. And then it cuts the decimals off. So it should be 0 to 9. It should never give us a 10. So it compiles now. Java's happy. No errors. And let's run it. And we get a 0 again. Did we just get lucky or unlucky? I don't know how to. Okay, let's try it again. Hey, we got a 4. Nice. Okay. And if you were to keep doing this, you should only get numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You should never get a 10. Okay? So, all right. So we've figured out how to create random number between 0 and 10, but it's 0 and it doesn't include 10. So then the other thing we can do is we can actually, what if I don't want 0? Smallest number is always 0, right? So we can shift math.random's output by adding a number. So if you want 1 through 10 and not 0 through 9, what we could do is we could add 1 afterwards. Or we could, add this result to 1. So we're going to get a number between 0 and 9. If you add it to 1, it's going to be 1 through 10 now. So we should never get 0 now. And we should never get 0 now. And we should get 10s now. So what we did was we moved all the numbers from 0 to 9 by adding 1 to every possible output. Now it's 1 to 10. So I would call that like a shift in the possible output. We could try it. I don't know if it's going to be obvious right away, but you should never get a 0. It would take a lot of tries to confirm that. And you should get a 10 every once in a while. But you're going to have to just trust me right now on this. I mean, what we could do is we could say, oh, there's a 10. We got a 10. Nice. Okay. You could set up like a little for loop, which we were talking about in the last demonstration, and have it just crank a bunch of them out just to see what all the possibilities are. Okay. Now, here's the deal. What if we want to make this program easier to use? What if I don't want 0 to 10 next time or 1 to 10? What if I want 1 to 100? And what if you know what I mean? So what we could do is we could kind of create variables for the upper and lower bounds so that we can more easily change them, okay? So lower, I'm going to create a variable of type int called lower bound, and that could be the 1, we want a lower bound of 1 and an upper bound of 10. So we could create variables to hold these. So if we want to change them, we don't have to go back through all the code to change them. We could just change them down here, up here, and then it's also kind of intuitive for someone else looking at our code. So instead of multiplying by 10, what we would have to do is we could do upper bound minus lower bound, right? Problem with that is that gives you 9. So you would always need to add 1 to that. So that can be the scaling thing, upper bound minus lower bound plus 1. And then here you could, instead of putting 1 in, you could put lower bound just to make sure that's where you started. So this would give us the same thing, and I don't know. It's kind of a little more, we can come up here and just make quick changes. Okay, so we have a way to create the random number. Now we got to get a guess from the user. So this is going to incorporate something new. And I want to create a variable to hold their guess. So I'm going to create a variable up here at the top. And I'm going to say int guess. Okay, so we're going to get a guess from them. So here, what we're going to do next, let's put an extra white line there just to break this up. Let's say guess equals. Now here's one way to get stuff from a user so they can type stuff in and interact with your program. It's called J option pane. Okay, so capital J, capital O. So this is a group of methods that are in Java already that you have at your disposal. Show input dialog. So this is like a method in there. Okay, now this is where you can give them a message. You could say guess a number between, and I'm going to put an extra space and then the quotation plus, and then I want to automatically put the lower bound and upper bound here. So this is kind of like, so we don't have to go and change all our code if we decide to change upper and lower bound. Guess between lower bound, which is actually a number, not a letter, but it will print it as like a letter with all these other ones, plus quotations. I want you to put an extra space between any kind of math operators or anything in here. Now this plus isn't actually adding this value to this value. It's adding this as a string to this string. It's adding a bunch of strings together. So upper guess between. Now here's a cool little trick. We can move this to the next line so it's easier to read. And Java is totally okay with this. And we can just kind of put it right there. As long as you don't put a semicolon, it kind of just reads the next line as part of the last line. So upper bound, so guess a number between lower bound, and maybe we should make it extra clear, inclusive, which means including that number, okay? So between or equal to, inclusive, and I'm going to do the next line. And I'm trying to just line these up close. They don't have to be lined up. This is just to make it easier reading. And upper bound plus inclusive. Okay, so 1 to 10, including 1 and 10. Because if you, yeah. Okay. And then we could end it. and then close the parentheses. So this is a message that will show up to them and also give them a way. It actually opens a little new dialog box. It's separate from that window we're used to. And then you got to put an ending semicolon on the end. Okay. So I just moved all this stuff to these next lines to make it easy to read. Otherwise, it would keep going over here when you'd have to scroll back and forth, and that would just be hard to read code unless your code isn't taking up as much room as mine. But that's just kind of a. And I don't think we need this extra space there. Now you need to worry about little extra spaces here because it's gonna. When you print this out and it looks weird, I want you to fix it and make it look nice. If you didn't kind of ahead of time see the problem. Now, what would be good is to then go ahead and print out for us right now the value that got stored in guess so that we can confirm that it's doing the right thing. Okay, so we'll print this out afterwards. And we'll print a random number also for now. Keep that just so we can test our code to make sure it actually works. Like know what the random number was and not just trust it. Now we go to compile and we have a problem here. Cannot find symbol, cannot find JSON pane. So sometimes when we do typos, and when we mistyped system the other day, it couldn't find it. Now here's the thing: a lot of these collections of things that we have access to in Java are automatically available, but some of them aren't, and we have to bring them in. So this is one of those things. JOption pane, you have to import it. So you have to go up at here at the top before public class and say import Java x.swing.jOption pane. We have to import it into our code. So this will do that. You got to put a little semicolon. So you guys need to add this to the beginning of your code. If you want to use this JOption pane, that's something we have to do. So that was the first issue. Then let's try and compile it again. Oh, incompatible types. It says a string cannot be converted to an int, meaning that what Java is going to get from the user, it's going to store as a string. Even if you type a number in, it's going to store it as like a symbol. So we got to deal with that. So let's create another variable of string type, and we'll call it input. So in other words, this is the input we're going to get from the user, and then we're going to have to somehow change it to a number that will store in guess. So here we're going to change guess to input. Okay, and that compiles, but then it says we can't print guess out because guess doesn't exist yet. Like it doesn't have an actual value yet. It hasn't been initialized. Okay, so this works. Let's see what happens when we do this. So pilot, right click, void main, left click. Oh, and it says guess a number between 1 inclusive and 10 inclusive. Okay, so I'm gonna guess 5 and hit enter. And then it prints it out over here. So it did store it. Okay. So that's it. That's all the program does right now. Okay. So how do we make that string become a number? Okay. So this is how we do it. We say guess equals, and there's this thing in the integer class that we don't have to import, capital I integer dot parse int, P-A-R-S-E, lowercase for the first letter, because this is a method, capital I for camel notation, and then in the parentheses, we're going to give it the input from the user. And what this method does is it changes a string that represents a number, like 5 or something, the symbol, and it changes it to an actual number in Java. So the symbol 5 is different than the number 5. So this will do it, okay? And then, so now we got a guess. Now we have to check it. So we're going to use some new tools here. This will give us an opportunity. So let's add some old comms here. Check to make sure user's guess is with so well, let's see. Let's just check user's guess. Check user's guess. Okay. And we're going to use something called an if else. Okay. And so an if else says if it is correct, what do we want to do if it's correct? If it is correct, let's print a congratulatory message. Hey, like you won or you got it right. Okay. So the way we're going to do that is we're going to use something called an if statement. And so what it's going to do, let's see, it's going to say if lowercase I parentheses guess equals random number. Okay. And this is going to have curly braces, just like all these other little things. And then it's going to have closing curly braces. End if. And so here's the way we check it. We don't say if guess equals random number with a single equals, because single equals in Java are used to assign values. If you want to check if two things are equal to each other, like in the mathematical sense, you have to use a double equals. Okay. So if that happens, let's print out a message. System.out.println. You guessed correctly. And then of course we got to close it in put a semicolon there. Okay. If they don't get it right, we got to print out some other kind of message. So by the way, this if thing says essentially saying do something, wherever it's going to be in the curly, do something if something else is true. So this is going to actually return a Boolean, true or false. And if it's true, it's going to do this. If it's not true, then we want it to do something else. So that's what will come next. Okay. If the guess is wrong, say so and print out the correct answer. We want them to feel like our code actually works, okay? Otherwise, okay, so the way we're going to do that, let's see. So the way we do that is we do it with an else. Okay, this is called an if-else statement. So if this, otherwise do this. Okay, and it's going to have its own curly braces. I'm going to say end else. And we're going to say system.out.println. Let's see. I'm going to say, I don't know. We could be mean and say wrong. Okay. And then we could print the other thing in a separate line. So you can do multiple things inside an if else system.out.println. So this will be on another line. We'll say the correct answer was, and this is where we're going to, it's called concatenation when you build strings off of other things. So the correct answer was, and then we're going to type in, we're going to use the variable name, random number, but we got to add that separately outside the quotations. So that should print out the main thing. So just to add a couple more notes here about how if else's work. So this is else, means like otherwise. Do this if it is false. So if that first condition up here is false, then it's going to jump down to here. If it's true, it's going to do this, and it's going to ignore this. Okay, so it's going to do one thing or the other. Now, we could actually check for the wrong answer being true. So, I mean, we could use if guess is not equal to random number. Now, the way you would do not equal, you would say, so pretty much this, the exclamation symbol as code means not. So this would be not equal. Could use this, but you know, it's just not as nice. Like we could do a separate if. We could do that if and do that if, but this is a little more slicker to just do it all together. So let's try it out. I think, you know, we got a lot of stuff going on here. Try and get all your code done. Like I said, pause the video and finish it. I'm going to compile it, make sure I don't have any mistakes. Okay. I'm going to go over here. Now, I still have those messages in there that print out the right random number because I want to check if this code works. I don't want to have to just keep doing it over and over again. So the random number is 6. So I'm going to put 6 in here and see if it works. Hey, got it right. You guessed correctly. Okay. Let's try it again, and let's purposefully choose a wrong answer. Okay, so just because it works in one situation doesn't mean so 5 is the correct one this time, so I'm going to do 4. Now yours are going to give you different random numbers. I'm going to do 4. You guessed wrong, and they did give me the right answer. Okay. Now another problem though that we didn't really talk about, and I'm going to do this in a separate video, is what if we guess a number outside the limits? Well, it's wrong, of course, but we could try and make it force us to give a good guess and not accept bad guesses. Okay. And also, by the way, what happens if we give it a letter or something? And we're not going to get super crazy, but if you type a letter in, it crashes because it can't change F into a number. So the parse int thing fails and your program crashes. So, and then it has this error code down here too. It tells you what line of code it's happening on, and it shows you in the other one. So, and then if you were to like guess a decimal, what would it do? So 5.6, would that work? Nope, it doesn't want it. It won't let you put a decimal into an int, right? So, anyways, that's it for now. And then I'm going to, and this is something that you can now start to use in assignment B, P1B. I think you guys now you're going to want to use if else's in that code. So you could start working on that. But we'll stop that for now. I'm going to add a little more to this in a separate video to talk about how we could force it to give us good guesses, at least number-wise, between the right numbers. I'm not going to talk about how to deal with the letters and decimal problem, but